Okay. Recording. Okay. So today we'll discuss all disk scheduling algorithms. One of the major overhead in disk I/O is the seek time. And in order to reduce this seek time, what we need to do is we need to select the minimum movement for disk arm. Okay, and for that, basically we want to see all disk scheduling algorithms. Now, seek time, we need to think in terms of cylinders. So for example, currently the head is pointing to some cylinder number, and then suppose any one of the process asks for some another cylinder number, then head needs to be moved from current cylinder number to whatever the requested. So that can be calculated simply by taking some sort of a difference between both. So for example, if you can see it here, the request queue is given as 98, 183, 37, 120. So all these are the numbers representing requested cylinders. So these are all numbers, right? And now head pointer is at 53. Okay. 53. Is at 53. Voice is breaking. First come, first serve. That is everyone. Can you hear me? I'm getting some responses. So yes sir, and some are saying yes sir, breaking. Question is, am I audible clearly? Okay. Okay, fine. So this was the first come, first serve. One of the example. The request queue is already given there. Now head starts at 53, and yesterday we did all the calculations. So it is very simple thing. On the top, these cylinder numbers are mentioned, like here it is 0, then 14, then 37, 53. So whatever the numbers required from the queue, they are mentioned here. And then we'll make use of a graph-like thing just to show you the movement, the displacement from current position to the required or desired cylinder number. So head starts at 53. So it is very simple thing, 53 to 98. So you can simply take this difference by 98 minus 53. Then from 98 to 183 because in the queue after 98 it is 183. So we discussed this part yesterday, and total movement of the cylinder is 640 cylinders. So number of entities is 1, 2, here it is 3, 4, 5, 6, 7 and 8. You can check it there. 1, 2, 3, 4, 5, 6, 7, 8. Total 8 maybe read or write requests are there. Okay, so starting from 53. So this is HCFS, that is first come first serve. Next algorithm is SSTF, meaning is shortest seek time first. SSTF, shortest seek time first. As the name suggests, it will select the request from the queue based on its current head position. Okay, so again the same example is taken where queue requests are 98, 183, 37, 122, 14, 124, 65, 67, and head starts at 53. Okay, now as the name of the algorithm suggests, it is shortest seek time, whichever is the location near to my current location will be served first. That is what SSTF is. So for example, currently I am at 53. So head start position is 53. From the queue, we need to select the cylinder number which is near to 53. That will be definitely resulting in minimum seek time, right? So out of these, the nearest one is 65. The nearest one is 65, right? So the movement required is 65 minus 53. That gives me 12. So in order to provide service to first cylinder request, 65 will be selected. Reason is currently I am at 53 and we want to have minimum seek time first. So nearest cylinder will be selected. And this will be repeated till there are requests in the queue. So this is kind of a shortest job first scheduling, and we are already aware this may cause some sort of problem of starvation if new requests are always coming there. Okay, so next will be definitely nearest to 65 is 67. So 67 will be served with total movements of 2. Next is 37. So we need to calculate the difference, and this difference is 67 minus 37. So that gives me 30. Okay. So after 37, next one is now what is remaining? 98, 183, 122, 14 and 124. because right now I am at 37, nearest to me is 14. Okay, so 37 minus 14, that gives me 23. So this 14 is also completed, right? Now after 14, out of remaining, the nearest one is 98. So 98 minus 14, that is the total movement required. That gives me 84. So that is 8 and 4. When this 98 is also satisfied. Now after 98, just 3 are remaining. That is 183, 122 and 124. Definitely, first of all, 122 will be served, and for that 122 minus 98, that gives me 24, right? After that 122, then 124. So just 2 head movements are required, 2 cylinders movement, and at last 183 is there. So 183 minus 124, that gives me 59, right? So total head movement, we need to sum it up. So it is 12 plus 2 plus 30 plus 23 plus 84 plus 24 plus 2 plus 59. If you sum it all, you will get it is equal to 236 cylinders. Now you simply compare the similar kind of thing what we did with first come first serve. That resulted in total head movement of 640 cylinders. Now 640 cylinders for HCFS versus SSTF, that is shortest stick time first, that results in 236 cylinders. So definitely this is more effective than SSTF, right? But again, the problem is whenever disc arm starts at, say, some sort of one end, okay, whenever you reach at the other end, say for example, in this example, say 199, now the distance between 14 and 199 is not 199 minus 14. Reason is very simple, it is circular, right? And because it is circular, maybe 199 and 14 is more closer than 199 and 37. And to exploit this advantage of hardware, another algorithm is used for that. That is called as scan algorithm. Okay, so scan algorithm is like the elevator algorithm, where it will start from one end and it will try to move towards the other end, and while moving it will provide service to in between requests, and whenever the head movement is at the other end, it will simply reverse the direction. So for example, maybe it is in between somewhere, and from that it will try to move either of them, maybe towards the beginning or maybe towards the end. Okay, so that is how this scan algorithm works. Again what we'll do is we'll see one example for this. Again, the similar kind of problem is there. Like for example, if requests are more dense at either end, other end has to wait for long. So kind of starvation problem is also there with scan algorithm. So now have a look at this. The same example, same queue, head will start at 53. Now it will select one end. Now for example here, what is selected is from 53 to 0. Okay. So now it will start traveling to the beginning, that is at the cylinder number 0. Okay. So because it has a 53, it will select the cylinder which is less than 53. So 3 cylinders are there. One is 37. Sorry, 2 are there. Just 2 are there. One is 37 and one is 14. So while traveling from 53 towards 0, the first cylinder it will come across is 37. Right? So 53 minus 37. Total movement required is 16. So it is 16. So this 37 is service. Next is definitely, so this is 37th cylinder. Next one is the 14. And this movement required is 37 minus 14. That gives us 23. So it is 2 and 3, 23. Now it even though see here 0 is there, but this is not in request. This is just used to denote that we have reached at the end. Okay. Now it will change the direction. So it will start from 0 to 0, 1, 2, 3 up to, say for example, maximum is 199 here. Total 200 cylinders. Right. So while going on that way, very first available will be 65. Okay. Now important thing, from 14 to 0, so this additional 14 will be required. That is one important thing. This additional part is definitely required, 14. Right? Then from 0 to 65, yes, 65 is required. So this total travel is 65 cylinders. Then 67, 2 more are required there. Then 98, so 67. So 98 and 67. So that total displacement is 31. So 31. So 98 is finished. Then 122. So 122 minus 98. So that is 24. Then for 124, 2 more are required. And at last 183. So it is 183 minus 124. And that gives us 59. Remember, in this algorithm, if 8 requests are in the queue, we are getting one additional head movement. So that is from 14 to 0. Okay. And now if you simply sum it, it is 16 plus 23 plus 65 plus 2 plus 31 plus 24 plus 2 plus 59 plus whatever the additional 14 is there, it comes to 236. 236. advantage of this scan is we are actually reducing the head movement in one direction only. Rather than going back and forth, what we'll do is we'll take one path and we'll serve the request on that path. Okay. Now you may ask the question why it is going from 53 towards 0. Not necessarily. Even you can go from 53 to 199 on that direction also. So only algorithm says that it will go on one end of the disk. It could be maybe left or maybe right, doesn't matter. So total head movement required is 236. I think it is on previous slide, no? Yes, it is on previous slide. 236 cylinders movement is required. So that is the scan algorithm. Next is C-scan algorithm. Next algorithm is C-scan, where it provides more uniform wait time even than the scan algorithm. Okay. Now in this algorithm, what happens is it is a slight change in scan. The head moves from one end of the disk to the other, servicing request as it goes. So this is exactly same like scan, but when it reaches the other end, it immediately returns to the beginning of the disk without servicing any request on the return trip. So in scan, what happened is, in scan algorithm, what happened is we modified the direction. Okay, so it follows only one direction. So when it reaches at one end, it will go to the beginning or end, depends. Like for example, if that end is the towards 0, it will move to the end, something like that. Okay, so it will not provide service on return trip. And just very simple reason for that is this will treat the cylinder as a circular list that wraps around from the last cylinder to the first one. Right? Now in this case, how you will calculate the total number of cylinders? That is the question. Okay. So for example, again let us try to solve the same thing with now C-scan. Okay. So for example, the same queue is there. Head will start at 53. Now say for example, the direction selected is from lower cylinder numbers to higher cylinder numbers. So 53 to 65, difference is 12. Next 65 to 67, difference is 2. Then 67 to 98, difference is 31. Yes, 31. 98 to 122, difference is 24. 122 to 124, movement is 2. Now 124 to 183. So 183 minus 124, that gives us 59. And 183 to 199. So 83 to 199 is 16. Remember, here we are not providing any service. Here we are just moving to one of the end. This part is important. This one. Okay. So still what is remaining? We need to provide a service to 14 and 37. Now here important question is, because we now reached at one end, here we reach, right, one end. So rather than reversing the direction, because if you reverse the direction, we need to move from 199 to say 37. That is how scan algorithm works. But what it does is, it will move from 199 to the beginning. That means to 0. Question is, how much movement is required? Is it 199 minus 0? Answer to this is no. Why? Because the assumption for C-scan is it is circular list. So from 199 to 0, just one movement is required, just one. Because it is a circular. So it is something like this. Okay. So you just need to count that as a 1. 199 to 0. Then 14 will be service, and then 37. So 37 minus 14. 23. And you need to sum these all. You need to sum these all. So here just two overheads are there. One is 16, because the highest cylinder number that we have serviced is 183, and to go to other end, like 183 to 199, 16 movements are required. And then in order to go to the beginning, because the nature of this disk is circular, because in those situations only this kind of algorithm is used. Okay. So this algorithm is C-scan. Okay. Now next algorithm is C-look. Actually now two algorithms are there, now I can say. There is something called as a look and C-look. After C-scan, there is something called as a look and C-look. Now what happens in this is, in look and C-look, now look algorithm is a version of scan, and C-look is a version of C-scan. Okay. Only thing in this algorithm, only thing is, rather than going to the end, it will go as far as the last request. So for example, if in previous example, if you saw like from 183, it moves to 199 and then 0, something like that. Rather than doing so, it won't go to 199, but it will go as far as the last request in each direction. Okay. So when you see the example, you will come to know that. See, for example, here. See, look. So from 53, this is see, up to 183, it is exactly same. Up to 183, it is exactly same. Now after 183, it will don't try to go to the end like 199. Rather, it will go to the beginning, and again not beginning at the 0. So in other direction, it is 14, no? So it will move to 14. So 14, and then, so this will be definitely helpful if it is, if requests are dense at somewhere in middle and not across the edges. Otherwise, C-scan will be better than that. Okay, so only change here is from 183, it don't goes here. No, it don't goes at the end. It don't goes at the beginning, that is at the 0, right? So directly from the last, that is 183, it will move to the first, that is 14. So this will be definitely helpful if your requests are like dense at certain, say for example like this. If my requests are something like this, they are centered, something like this. Okay, so it will make movement something like this one, beginning, something like this. So less number of head movements will be required for that. Okay. Now the algorithms we just discussed are for disk scheduling. FCFS we studied, then SSTF, then scan, then slight variation in scan is C-scan, then look, or directly I can say C-look. 5 algorithms with the same example we have just studied. Now we need to do some sort of analysis, like which algorithm to use, how to select the algorithm. Okay. So few concluding remarks are there. SSTF is common and has the natural appeal, like whichever this SSTF definitely reduces the head movement. Scan and C-scan performs better for system that place a heavy load on the disk. There less starvation is there. So back and forth movement are reduced there with scan, C-scan. Anyways, performance depends on number of and types of requests there. SSTF or look is reasonable choice for the default algorithm. Rotational latency is not typically considered because it is really difficult for operating system to calculate it. Next part is disk management, but we'll just have a discussion on this slide only, and then disk management will stop here. Okay, because that is again how the master boot record is organized. That part we have seen when we discussed about booting process. The important part is the concept of formatting, something called as a formatting, where 2 types of formatting are typically used if you are formatting your pen drive. Say for example in Windows, you will come to know something like quick formatting and low level formatting. Okay. So now there are 2 ways. The low level formatting or physical formatting will divide the disk into sectors that the disk controller can read and write. Okay, so that is what the low level formatting is, where each sector can hold header information plus some sort of data and error correction codes. Most of the time, typically 512 bytes of data it can be selectable for that purpose, where that is stored for disk controller, right? Whereas another type of formatting is logical formatting. Now, just I give an example of when we right click on pen drive or any of the D drive, E drive, whatever. Okay. So first upon, when I say D drive or E drive in case of Windows, right? So when I say D drive, that means you have already divided the disk. Just now you are formatting it. So that is what the logical formatting, where you are installing some sort of data structure there, and that we call it as a file system. FAT32 and TPS. These are names of file system in case of Windows, where in case of Linux operating system we have something called as ext 4. Even ZFS is more popular in storage devices. Okay. So that is what the logical formatting is there. So first upon, we need to have a group of cylinders that will be treated as a logical disk. That is what we call as a D drive. And when we format it, that is what the logical formatting. So two levels of formatting, always remember. Physical formatting, that is required for disk controller. And logical formatting is required for making the file system. Okay. Always remember, whenever there is problem with hard disk, complete hard disk, it is the problem with all the partitions. Always remember that. And solutions we discussed yesterday with RAID, redundant array of independent disks, with different RAID levels, with multiple disks, with storage arrays, and with SAN, storage area network, or NAS, network attached storage. So you should be aware of all these facts. Okay. Now that is all for this disk management. Do you have any questions? Now questions related to first upon disk management, and then we'll talk about our submission and internal related thing. Just a minute. How many participants are there? 70 participants are there. See, let me tell you, out of this unit, half part is now just we have finished. Now what is remaining is just IO management. Maybe 2 lectures are required. What I'll do is I'll simply record it and put it in Moodle. Even all previous lectures also I'll share on Moodle. Just some part is still remaining regarding the conversions. So that I'll finish maybe in today or tomorrow, and all lectures will be available to you. Okay, that is as far as syllabus is concerned. So after 2 lectures of IO management, I think today is अच्छा आपला लेक्चर कितवा आहे?